Hi guys, and welcome back. I hope you are all successful in finding the sum, the mean, and the standard deviation of all three classes combined. And now I will be showing you guys the answer. So we'll start off by giving ourselves a little bit of space in our R script. And I'll start by creating a new object called sum.grades. And then I will set it equal to the sum of class 1, class 2, in class 3. And if I run that line of code, we can see that we have sum.grades printed up in our environment. And I think I've been demonstrating to you guys how to print objects by simply writing the object and then running the line of code. But there are a couple different functions that can be used to do that. Sometimes they can be helpful in other data analyses that you guys work with. So we can use the print function. So if we simply write print and then we put sum.grades within the print function, we also get our 2431 printed out that way. And lastly, we can also use the paste function where we can put sum.grades and run that line of code, and we can actually paste the value of sum.grades. It's going to put it in parentheses, but those are just a couple different ways of printing values in R. So now we have the sum of all the grades, which is 2431, but we also wanted to find the average value of the grades. So if I type, I'll create a new object called average grades, and then I'll set it equal to the mean of class 1, class 2, and class 3. And when I run that line, we actually get an error. So you can see that error is printed out in our R console. Error text will always be in red. So that shows you that there's a problem going on in your R code. So what is this error? Well, if we read it, we can see error in mean.default. The trim must be numeric of length 1. The condition has a length greater than 1, and only the first element will be used. So that doesn't look good. Actually, let's take a look under the hood of the mean function to actually see how it's operating. So if you want to better understand a certain function in R, you can use this help window. So I'll start off by writing on line 46, I'm going to type a question mark, and then I'm going to type the function that I'm interested in. So we want to understand how R is interpreting the mean function. So I'm going to use a question mark and then the function, and then I'm going to run that line of code. And then in our bottom right-hand window, we can see that the help function is now describing the function, which is mean. So if we look at mean, it looks like we're going to start off, the first element of the mean function is an object called x. So that's the object that you would like to find the mean of. So we can see that the argument here is x. X is an R object. Currently, there are methods for numeric and logical vectors and date and time intervals. Complex vectors are allowed for trim equals 0 only. Okay. So if we look, also, if we scroll all the way down in our help menu, we can look at a couple different examples. So let's say we had a vector that was called x, and it was equal to the values from 0 to 10. So if we took the mean of all those values, we would get a certain answer. It doesn't actually give us the answer, but we can see that when we're trying to find the mean of a given value, we can only have one value. So I think the error that was occurring on line 45 is that we're trying to find the mean of class 1 and class 2 and class 3, but R only wants you to give one object. We have 3 different objects they're trying to find the mean of. We actually need to combine all of those objects into one object, and then we can find the mean. So how are we going to combine all of the grades from 1, 2, and 3 and store them in as one object? Well, we're going to have to use the concatenate function that I think we described in class 1. So we can do that by creating a new object called all grades, and we'll set it equal to the concatenate function of class 1, separated by a comma, class 2, and then separated comma, class 3. So we're going to combine all of the grades in the 3 classes into one object that's going to be called all grades. And then we can run that line, and in our console, we can take a look at all grades, see what it looks like. And we can see that all of the grades from the 3 classes are now printed out and stored in the object called all grades. So now I think we'll be able to find the mean of the 3 classes. So let's say I'm going to create that other object, all grades, that we wanted to create earlier, and then I'm going to use the mean function, and then I'm going to find the mean of all grades. So if I run that line of code, we don't get an error function, which is good. We can see that the text is blue and R was successful at running that analysis. And then we can type in our R script and print it out and run line 50. And we can see that the mean of all of the grades in the 3 classes is equal to 81. So just an important concept when you deal with that error message that we had earlier, that's because you can only find the mean of one object. You can't find the mean of 3 separate objects. You have to combine those objects into one object, and then you can find the mean. So looks like we are doing pretty well. Let's actually take a look at the classification of the object called average grades. So we can do that by running the class function on average grades. It looks like R is understanding average grades to be a numeric variable. But let's say we wanted to turn that into an integer variable. So we want to maybe get rid of those decimal places and just have it stored as a round number. So let's create an object called int.average grades. And we can set it equal to, let's use the as.integer function, and we're going to round the value of average grades. So again, we're going to work our way from in to out. So first we're going to round average grades. So hopefully that will change it to the value 81. And then we want to tell R to convert that numeric variable to an integer. So if we run line 53, then we can look at the structure of int.avgrades. We see that R is now interpreting this value as an integer, and it's stored as the value 81. So those are just a couple important concepts. I don't think I actually asked you to convert the values, but just kind of building on some of the things that we were working on earlier. So I think the last task that I asked you guys to do was to find the standard deviation of all the grades. So let's create an object called standard deviation grades. And we'll set it equal to the standard deviation of class 1, class 2, and class 3. And it looks like we're getting another error. We get the red text says error in standard deviation, unused argument class.3. Now, I'm probably going to assume that the same issue that was occurring on line 45, where we were trying to find the mean of multiple different objects, we probably just need to store these classes as one object. So we've already done that when we created all grades on line 48. So let's actually do something similar where we can create an element called standard deviation grades, and we'll set it equal to the standard deviation of that object we created earlier, which is called all grades. So if we run that line, we don't get an error argument, and we can print out the object by typing on line 59 and running that line, and it looks like the standard deviation of all of our grades is 9.7. So hopefully you guys were able to work on some of those questions on your own, but if you didn't, that's okay. You have the answers now. And now we will be moving on to the next section of our course, which I'm going to call Working with NAs. So what are NAs? Well, they're essentially null values or values that R is having a difficulty interpreting. They're not numeric variables. They're not character vectors. They're kind of just blank or null values. So let's create an object by that's called allgrades.nas. So we're going to use that previous object called allgrades, but we're going to add an NA value to it. So I'm going to set it equal to, you're going to use the concatenate function because I'm going to add an NA value to the original object called allgrades. So I'm going to type allgrades. And then I'm going to put a comma, and then I'm going to type NA. And as you probably have noticed, when you type NAs in our R script, they actually are interpreted, they're actually printed in blue, kind of like when you put a numeric element in our R script. You can see that numbers are in blue. So NA values are also in blue in our R script. And if we run that line, let's take a look at how R is now interpreting this object called all.grades.nas. And we find that this object is equal to all of the grades that we've previously have worked with, but on this 31st element, we have an NA. So we have all the grades that we were working with earlier, and then we have this last grade, which is an NA. So let's try to, and this is why I demonstrate this example with NAs, is that NAs are very common in all sorts of data sets that you'll work with in all different industries. And all the functions that are built in R interpret NAs differently. So let's try to find the mean of this new object called allgrades.nas and see how R interprets these values. So as you can tell, R is not actually able to find the mean of all grades when there's an NA value. Obviously, its output is in black here. We're just getting an NA. So let's go back to that help window that we were working with earlier. We can see that we're working with an arithmetic mean and the mean function, but there's this interesting argument that's called na.rm, which says a logical value indicated whether NA values should be stripped before the computation proceeds. So there is an argument in the mean function that is designated by na.rm, which actually stands for NA remove. So R will remove NA values, and then subsequently it will interpret the mean of a given object. So that's actually what we wanted to do because you can't take a mean of an NA value. So we can work with NAs in the mean function by trying to find the mean of all grades.nas. And then we're going to use a comma, and we're going to put this argument na.rm, and we're going to set it equal to true, which is going to tell R to remove the NA values before you find the mean. And if I now run that line of code, we see that the allgrades.nas is actually equal to 81.03, which I believe is the value that we had earlier. So when you're trying to find the mean of a vector that has NA values in it, you want to use this argument na.rm and set it equal to true, which tells R to remove the NA values before you find the mean. So let's now move on to a standard deviation example with NAs. So I'll use the standard deviation function, and I'll type allgrades.nas. And again, we're getting an NA value because R is not able to find the standard deviation of a null value. So again, we're going to use that na.rm function. We will type SD, the standard deviation function, put in our object, which is called all.grades.nas. And then we're going to use the na.rm, the na remove argument. We're going to set it equal to true. And now if we run that line, we get that value that we got earlier, which is 9.71. So when we remove the NA value, then R is able to subsequently find the standard deviation of your vector. So let's move on to our second in-class assignment. And in this assignment, I actually want you to find, how would you code code 8 sequences of 10 to 100 at intervals of 5? So I'll just formally write this out. How would you code 8 sequences of 10 to 100 at intervals of 5? So this is going to, I'll give you a hint. This is going to involve the rep and sequence functions that we touched on earlier on in the course. And this hopefully will be a short assignment. Just should take you a couple minutes, but you can pause the video and tune back in and I will show you guys the answer. Thanks.